So we're going to look at some exercises to do with the intersection of two lines in 3D space. I've got a couple of questions here for you. I want you to read the questions, pause the video, have a crack at them and come back and check your answer with what I'm going to show you here. So here's the questions. So I've got two questions here for you. First one, I just want you to show these two lines intersect. And then the second one, I want you to find the point of intersection and the angle between the lines. Now, quick pointer for you, just because the question says find the point of intersection doesn't necessarily 100% mean that they will intersect. 99% of the time, don't get me wrong, they will, but that's just the way the questions are worded. Sometimes they won't intersect at all, and you'll find that in your working. So bear that in mind, have a crack at these, and then come back and check your work. So, first one was show these two lines intersect. Now remember, for this we had a set of steps to follow. First, we had to write it in parametric form for each line. Then, we had to equate the like terms, so the x's, the y's and the z's, because when we made them parametric, we'd set 1 equal to the variable t1 and 1 equal to the variable t2. Once we've got that, we solve a pair of those equations for t1 and t2 and use our third one as our checking equation to make sure it holds. Then we can use that to find the point of intersection. So what I'm going to do is take this first one, call it my line 1, and I'm going to set that equal to the t1. Second one, I'm going to imagine is called line 2, and I'm going to set that equal to t2, and then I'm going to get both of them in parametric form. So line 1, I'd get for x being 2 plus t1, y is equal to 2 plus 3t1, and z is equal to 3 plus t1. Second one, line 2, which would be this one here with the variable t2. What I'd end up getting for x is I'd get x equals 2 plus t2, y is equal to 3 plus 4t2, and z is equal to 4 plus 2t2. Now that I've got that, equate each of the terms, so each of the z's together, each of the y's together, and each of the x's together to get equations based on the two parametric variables t1 and t2. So I'd have 2 plus t1 equals 2 plus t2. Solve that, shift it across. What I'd end up getting is t1 minus t2 is equal to 0. Second one, I'd have 2 plus 3t1 equals 3 plus 4t2. Again, same idea, shift it all onto one side for the t variables, all the numbers onto the other. What I'll end up getting is 3t1 minus 4t2 is equal to 1. And then the last one, my 3 plus t1 equals 4 plus 2t2. Shift it about similar fashion. I get t1 minus 2t2 equals 1. So now I pick a pair of them so that I can solve it for t1 and t2. What I'm actually going to do in this case is pick the first and the last, because you'll notice that the coefficients of t1 are equal to each other. So if I say, right, so I've got t1 minus t2 equals 0, I've then got t1 minus 2t2 equals 1, and I subtract them from each other, what I'll end up getting quite simply is that t2 equals negative 1. And if I then substitute them back into there, I get t1 minus minus 1, so t1 plus 1 is equal to 0, so t1 is also equal to negative 1. Now I've never said you can't have the parametric variables equivalent to one another. What we now do is we use our third equation as our checking equation. So in this case, I'd use this equation here. So what I then say is fine, so 3 times t1, so 3 times negative 1, take away 4 times negative 1 is equal to negative 3 plus 4, which is equal to 1. So our equation holds in this case for the parametric variables, therefore the two lines intersect. If I was to then go on and find my point of intersection, what I could do is take either of these two parametric variables, t1 or t2, and substitute them into the equations here. So if I was to take t1 for example, I'd have 2 minus 1, so I'd get 1. I'd then have 2 minus 3, so I'd get negative 1. And then I'd have 3 minus 1, so I'd get 2 for that. If I was to do the same for this one here as well, I'd get 2 minus 1, which again is 1. I'd get 3 minus 4, which is minus 1. And I'd get 4 minus 2, which is 2. So I'd get the exact same point of intersection if I use T2 as well. So there you go, the two lines intersect, and as a wee bonus feature, there's the point of intersection. So the second question, I wanted to find the point of intersection and the angle between the lines. So this time I've got that extra added part that I need to do is find the angle between the two lines. Now this question does imply that they're going to intersect, so first we have to start by proving that, then find the point of intersection, and then the angles. But none of the steps change for finding the point of intersection. First we have to prove they do, so set the first one equal to the variable t1, second one equal to a variable t2, and rewrite them in parametric form. So that first line, L1, which is the t1 line, what we'd rewrite that as is x equals 5 plus 4t, y equals 7 plus 4t, and z equals negative 3 minus 5t. If I then look at the second one, so line 2, what I'd end up getting, so each of these should have a t1, 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 just to make sure that they're different. Second line, my x would be given by 2 plus t2. My y would be given by 3 plus 4t2. And my z would be given by 4 plus 2t2. So now that I've got that, what I do is I equate the corresponding parts. So I equate the x's to each other, the y's to each other, and the z's to each other. What that will then allow me to do is say that 5 plus 4t1 equals 2 plus t2, 7 plus 4t1 equals 3 plus 4t2, and the last one, negative 3 minus 5t1 equals 4 plus 2t2. So what I can now do is take each of these and rearrange them so I get all the t1s and t2s on the same side. This first one will give me 4t1 minus t2 equals, take the 5 across and I'd get negative 3. Second one here would give me 4t1 minus 4t2 equals 3 minus 7, so that equals negative 4. And then the third one here, that would give me 5t1 plus 2t2 equals negative 3 minus 4, which is negative 7. So what we do now, we pick a pair of equations to solve, and then we use the third one as our checking equation. So I'm going to pick these two to solve, because if I subtract them, I've got 4t1 on both of them, so the t1s will go. So they'll disappear. I'll then have negative t2 minus minus 4t2. So negative t2 plus 4t2. That'll give me 3t2. I've then got minus 3 minus minus 4. Well, that then gives me minus 3 minus minus 4 gives me 1. So I then end up with t2 is equal to a third. What I can do is take that third and substitute it into either of these two equations. So let's look at the top one. For that, I'd then end up with 4t1, shift the t2 across, equals negative 3 plus a third, which is negative 8 over 3. Divide through by the 4, and I get that t1 is equal to negative 2/3. Now that I've got that, I can use the third equation to check. So if I substitute into that third equation, I should hopefully get that solution there. So if I were to do that, I get 5 times t1, so 5 times negative 2/3, plus 2 times a third. That would equal 5 times negative 2/3, so that would equal negative 10 over 3. Plus 2 over 3. What that would then equal is -8/3. So what I've actually proven in this one is that these two lines don't actually intersect. So as I talked to you about at the start of the video, don't take it as given that when it says find the point of intersection, they actually physically will intersect. Sometimes they don't. It's just a misleading question. Now it said about finding the angle between the lines. Quick pointer on that. To find the angle between the lines, use the fact that we can say that cos theta is equal to A dot B over the magnitude of A, magnitude of B. Now A and B here are the direction vectors of both of our lines. So if these two lines did intersect, what I'd do is I'd set A equal to the direction vector 4, 4, 5, sorry, -5, and I'd set B equal to the direction vector 1, 4, 2, and then solve this formula using them to get the angle theta between the two lines. So if we're asked for that part of the question, that's how we would do that and how we'd accomplish that task too. In this case though, they don't intersect, we can't find an angle between the two of them. So just remember these key points of information and these key skills. We need to know them all when we're working through these types of questions and when we're having a crack at this type of material, looking at the intersection and angle between lines in 3D space.